All right, everybody ready? 8F. Today we are looking at the graphs of the exponential and the logarithmic functions. So you know that if we have an equation y is equal to a to the x, then it's going to be an exponential graph. We've graphed these before. It's called exponential because it has an exponent, and your exponent is the x. The x is the power. Our log function, this is going to be a new type of graph. It'll be y is equal to log some base of x, and that's going to be our log function. The two graphs are very, very interesting. It's why we learn about them together, because they are a reflection of each other, and they reflect across the line y equals x. And you can see that down here in this diagram. So the first graph that you've been given is the y equals 2 to the x. You know this one, you've drawn these before, our exponential graph, it looks like this. And this curve down here is what a log graph looks like. This is log base 2 of x. And if we draw the y equals x line, they are a reflection of each other across that line. Okay, and what that means is that you are switching the x and the y values. That's how you get a reflection. Okay, so what do we know about those graphs? For the y equals 2 to the power of x, our exponential graph, our domain is all real x. You can have any x value you like, all real x. Our range though, our curve is always above, or at least for this one, it is all above the x-axis, which means that our range, our y, is always greater than 0. It will never hit the 0 because that is an asymptote that it is approaching. Another way to describe it is that the curve is always increasing and it is getting steeper all the time. That's what we mean by exponential increase. It's getting steeper and steeper and steeper all the time, and it is in an upwards direction, which means it's concave up. However, when we do our logarithm and we switch our x's and y's around, it means that our x value now has a restriction. Our logarithm here is approaching the y-axis, but it will never actually touch it, which means that our x values are always going to be positive. They're always going to be greater than 0. Our range, though, is now freed up. We can have any y values down here, and our y values, the positive ones, although it doesn't increase very steeply, it will keep increasing forever, just much slower. Okay, so it is still increasing all the time. However, it is now facing down. It is a concave down graph. All right, so here we go on the next page. We're going to sketch some different types of graphs. We're going to start with the exponential. When you draw these graphs, there are three or four main things I'm looking for. If you can do the three, the fourth one should be obvious. The three things that I'm looking for are, you've got an asymptote where it needs to be. You show me where the intercept is, and you should show me one other point at least. You can show me more. So intercept of the axes, and one other point. The fourth thing is that you've shown a reasonable diagram of what the graph looks like. You've got the slope going the right way. Okay, if you get those other things, then it should be very easy to get that fourth thing right. Okay, so if I'm going to sketch y equals 3 to the power of x, I'm just going to do one at a time. I'm going to start with that one. I'm going to draw a nice big Cartesian plane. As soon as I see that equation, I know that it is an exponential graph. And unless I have been messing with minus signs or adding things on the end of it, it is always going to have a horizontal asymptote at y equals 0. Okay, so across here, I'm going to should be sitting right on that green line. So there's my asymptote, and I label it horizontal asymptote at y equals 0. Okay, so the other thing that I said I wanted was an intercept. And for exponential graphs, it's going to be a y-intercept. If I sub in that x is equal to 0 into here, 3 to the power of 0 is 1, which is also very typical of an exponential graph, unless I add things onto it or put minus signs in there. It pretty much always goes through that point 0, 1. Then, as I said, I want one other point at least. The easiest point to get is when x is equal to 1. If I sub x is equal to 1 into that equation, 3 to the power of 1 is 3. So 1, 2, 3, that will be up here. As long as you know that that's an exponential graph, that is enough information to draw the rest of it. You just need to make sure it's curving. So it comes down, it's going to curve through my intercept there, and it's going to approach that asymptote. Do not let it come back up here. Make sure that it looks like it's going to keep approaching. Make sure that I can clearly see your y-intercept, and please also clearly label your extra point, because when I mark these, I go asymptote check, intercept check, extra point check, and you get the full marks as long as your graph is sloping correctly. Okay? All right, let's do the second one. We now want to draw y equals 3 to the negative x. What's that going to do? Has it moved my asymptote? No. Okay, so that part stays the same. That's already done for me. My intercept, let's do a check. If I sub in x equals 0, 3 to the negative 0 is just 0. 3 to the 0 is still 0. So it's still going to be going through that point 1 there. Then I need another point. Now, normally I would sub in 1, and you can sub in 1. Because it's a minus sign, though, if I sub in negative 1, it makes it positive again. It makes it nice. Okay, if I sub in negative 1, minus 1 is positive 1. 3 to the positive 1 is 3 again. Okay, so I'm going to go minus 1 is back up here at 3. And all that putting that minus sign in has done is reflected my curve across the y-axis. Okay, I've got my horizontal asymptote, I'm showing my y-intercept, and I'm also going to label my extra point, minus 3, 1. Okay, there is an extra part to this question. It does say to state the domain and range. So for my red graph, that was my y equals 3 to the power of x graph. The domain, the possible x values, I can have any of them. I can have any negative values this way. I can have any negative values of x that way. So it's all real x. The range, looking at the y values. I can have any y values up here, but I'm never going to get any negative y values. All of my y values are going to be greater than the 0. They can't hit that asymptote. So y is greater than 0. Okay, how about for my blue graph, which was the y equals 3 to the negative x? My domain hasn't changed. It's still all real x. And my range hasn't changed either. It is still above that asymptote, and it is still y is greater than 0. Okay, so how can I change my domain and range? Example number 2. This time we're going to sketch the y equals 3 to the x graph again. We've already done that, so let's quickly do that. Same as before. So the horizontal asymptote is going to be at y equals 0. Make sure I can see the dots. Make sure you've put the HA y equals 0 on the side of it. My intercept, when I sub in 0, I get 1. And when I sub in x as 1, I get y is 3. I'm doing that quickly because it's exactly what we did last time. Okay, so there is my y equals 3 to the x graph again. While I'm there, let's write down, because it says domain and range. Domain is all real x still, and the range is y is greater than 0. All done in question 1. So the new part for this question is that we now want to add the graph of y equals minus 3 to the power of x. So we're putting the minus sign in front of the 3 this time. What is that going to do? Is it going to move my horizontal asymptote? No, correct. So let's find our y-intercept. So I sub in when x equals 0, minus 3 to the power of 0. Now be careful with that. You do the 3 to the power of 0, which is, and then you put the minus sign in front of it. So it's minus 1. Okay, so there is my new y-intercept. Then I need another point. What should I sub in? All right, let's do 1. So 3 to the power of 1 is 3. With the minus sign in front of it makes minus 3. So that's down here. So I'm going to draw my exponential curve, going through my y-intercept, through my extra point, and I'm going to label that extra point 1 minus 3. Okay, so a minus sign in front of the x flips it across the y-axis. A minus sign in front of the 3 flips it over the x-axis. Okay, so that's, oh wait, I didn't finish. I need to do the domain and range of that one. My domain is, what are my x values? I can still have all of them, all the positive, all the negative, all real x. What about my range? Yeah, because it's been reflected down here, I can now have all the negative values and none of the positive ones. So it's now going to be y is less than 0. Okay, so hopefully that's all familiar. We've done exponentials before. Here comes the logarithms. Question 3. Because this is new, I am going to draw some tables up to get us started. And then you might be able to get to the point where you're just able to do what we do in the exponentials there, where you just need your asymptote, your intercept, and one extra point. Okay, but we'll start with the table so you can see the full thing. All right, so the first one that we're going to draw is y equals log base 2 to the x. So my table that I'm going to use is going to be, I showed you a logarithm already. Remember that it's had an asymptote at 0. There's actually, I can't use any negative values for x. So I'm going to start close to the 0, which I'm going to start at a quarter. I'm going to pick some small values, a quarter, a half, and then 1, and then I'll just go up by 1s from there, 1, 2, and 3. Now we need to be able to find the y values. Can we do a log base 2 on our calculator? No. So you're going to have to do a change of base to find those in your calculator. So that would be log base, what base do you want, 10 or e? 10. Log base 10 of a quarter over log base 10 of 2. Do you remember to write that down? So this was, to get that first one there, I'll write it up here. If we're trying to find log base 2 of a quarter, that's what we're trying to sub in there. But to type that into our calculator, we do log base 10, if we're changing it to a base 10, of the number on the end over log base 10 of the original base, which was a 2. So you can choose a base 10 or a base e, it doesn't matter which one, as long as you use the same one for the top and the bottom. And you type that in. What do you get? -2. Okay, now do the same thing for a half. The only thing that's going to change is that number there. The bottom part of the fraction still stays the same. There's still a base 2 here. So it's going to be log base 10 of a half over log base 10 of 2, which is -1. Good. Okay, it's good practice with our change of base. Try 1. It's going to be log base 10 of 1 here over log base 10 of 2, which is 0. What about 2? Yeah, and then 3. It's 1.6 if you round it, isn't it? All right, good. Okay, so let's draw that. Now, I don't have any negative x values, so I'm not going to draw much on that side of the graph. I have 1, 2, 3. Okay, so at a quarter, and you've got to try and approximate where a quarter is on your x-axis. At a quarter, my y value is -2, so down here. At a half, I'm at -1. 1 is 0, 2 is 1, and 3 is 1.6. And there's my logarithmic curve round there. Okay, it's kind of the reverse, isn't it? It's the inverse of that exponential. I have shown, for my logarithm, I have shown my x-intercept. I should show one extra point on there clearly, which I'll choose this point here, 2, 1. So that was a nice even point to put on there. The other thing I need to show is my asymptote. Where's my asymptote for this graph? X equals 0, correct. This one here, this is where my asymptote is happening. It's approaching this line. So I need to draw my dotted line coming down here. It is now a vertical asymptote at x equals 0.
Would then you want it 2 as well? Y?
No, this is actually not going to be approaching just the 2. It will keep climbing continually. Okay, it doesn't flatten off completely. It just climbs slowly. Okay, now let's draw the other one. What happens if I put log base 2 and I have some brackets in there, that x minus 1? Do you want to have a guess before we work it out? It's going to shift one way. Which way?
Right.
So
I'm going to go plus.
So my asymptote is going to move to
Right.
plus 1. Correct. Good job. Yes. All right, let's draw the table though, because I think it's good practice for you guys doing your change of base. So for my second curve, because we know that it's moved one space to the right, because of that -1, I can't pick any x values that are 1 or less. It has to be 1 or it has to be bigger than 1. Okay, so I could start at 1 and a quarter and 1 and a half. Then I could go 2, 3, 4. Does that make sense? Guess what happens when you type those in? Do the first one. You're going to do log base 10 of 1 and a quarter over log base 10 of 2. What are you going to get? -2. -2. All the y values are actually going to be the same because my graph has just been moved across horizontally one place. Okay, so I'm going to draw that in a different color. What's a good color? Purple. Okay, so at I have a vertical asymptote here. So vertical asymptote is now at x equals 1. And my points at 1 and a quarter, I'm at -2. At 1 and a half, I'm at -1. At 2 is 0. 3 is 1. And 4, or I should add an extra value on here, 4 is 1.6. So it's coming up like that. Okay, so the whole graph has just been moved one space to the right. Okay, they're drawn. I want to show their domain and range. Let's start with the first one. My original red graph there. My domain, can I have all the x values? No. I've got an asymptote here, and I have all the x values that are bigger than that.
X
So,
has to be bigger than 1.
not for the red one, bigger than 0 for the first one.
Oh, my goodness, I missed.
Okay, the range, all real y, correct. I can have all the positive, all the negative. There's no restriction for the range. All real y. Then my purple graph.
Oh my god, oh, I thought we were doing the purple graph.
Now I'm doing my purple graph.
Now this is X has to be bigger than 1.
Domain, yes. I have my asymptote at 1, which means my x values have to be greater than 1. My range is all real y still. Now, one thing I have not drawn on my second graph was my extra point. So let's come back and do that. I need my point 3, 1 on here. So I've shown the vertical asymptote, I've shown the x-intercepts for both of them, and I have shown one extra point. End state of the domain and range. All done. Okay, question 4. Sketch both log base 2 of x, that's the one that I just did. That's the same one again. But the second graph, y equals 4 plus log base 2 of x. What is that second one going to do? Move it vertically, that's right, up 4. Okay, so let's see if we can do this the shorter way. Draw up our Cartesian plane. Without the table, I mean. So I know because it's a logarithm for my first graph, even though I just drew it, if I was doing it without the table this time, the basic logarithm will always have a vertical asymptote going through x equals 0. So vertical asymptote at x equals 0. Then I'm trying to find my x-intercept, which is pretty much always going to be one space across from there, which is going to be at the 1. And you can check that by subbing in. If you sub in x equals 1 into there, and by the way, you don't need to do a change of base for that, 2 to the power of what gives 1? 0, which is y equals 0 at that point. Remember, there are some logs you can do without doing a change of base. Okay, you could also do 2. Let's do 2 for our second point. 2 to the power of what gives 2? 1. So at x equals 2, we are at 1. Okay, then we know what our basic curve should look like, so we can draw the rest of it in. My asymptote is there, my intercept is labelled, and my extra point is shortly going to be labelled 2, 1. And there it is. Okay, so we know what we're expecting to happen with our next graph. Is my vertical asymptote going to move? No, because I'm shifting it vertically, not horizontally, right? So that's going to stay the same, the x equals 0. But when I sub in 1, 2 to the power of what gives 1? 0. But I've got to add 4 to that. So it now becomes a 5 up here. So at 1, we're at 1, 2, 3, 4, 5, way up here. Okay. That is not my intercept. 2 to the power of, what was I adding? 4. Oh, yeah, no, it was at, yeah, sorry, right, 4. At 4, because it was 0 plus 4 is 4. So then, that is not my intercept, right? That's going to have to be my one extra point. It's not my intercept. So 1, 4. I'm going to have to find my intercept, which unfortunately is not as easy to get. To find the y-intercept, you want to sub in that y is equal to 0 into that equation, don't you? So I'm going to put 0 equals 4 plus log base 2 of x. I have to solve that to get the x. So I move the 4 across, minus 4 equals log base 2 of x. And I'm still trying to find the x, so I'm going to have to do a sliding base. Slide the base 2 across to the other side, it'll be 2 to the power of negative 4 equals x. Now you can find that as a decimal. That is equal to approximately 0.06 as a decimal, or 1 over 16 if you leave it as a fraction, which is exact, which is probably better. Okay, so right down here, very, very small, there is going to be an intercept at 1 over 16. And my graph is going to come down
Whoa.
like that.
Oh. I thought that one was
So I have shown my asymptote, I have shown my intercept, and I have shown an extra point. I still need to do the domain and range.
Oh, John.
So the domain of the red graph, what x values can I have?
All is greater than 0.
All the positive ones, that's right, above that asymptote, so greater than 0. The range, yes, all real y. Now for my second graph, what is my domain?
X greater than 0.
X is still greater than 0 because I didn't move my asymptote. And what's my range? Still all real y, so I didn't change anything. All I did was move it up and down a bit. Okay, so when you're setting these out, I suggest that you do them like mine, where I've got my domain and my range written next to the right curve like this. Or if you don't have room for that, you could actually rewrite the equation. So the y equals log 2 to the x, domain is this, the range is that. Okay? Remember, you are showing the 3 key features: asymptote, intercept, and extra point.